Hello, Knights. This is Mr. Widener. I'm part of the Algebra 2 team, and I wanted to share with you something interesting that happens when we look at the graph of y equals 1 over x. So here I have that graph on decimals. When I graph it out, something interesting happens. I get this kind of weird graph. One of my students said it's kind of a weird two-part curvy thing, which is a pretty good explanation, I think. So 1 divided by x gives us this graph. And if you think about what happens when I put in big numbers into in 4x into 1 over x, I get 1 divided by that big number. I can show you in decimals if I edit my list and make it into a table here. What if I put in a number like 5? I get 0.2. If I put in 10, I get 1 over 10 or 0.01. If I put in 100, 1/100th, of course, 1/1000th. Okay, these really little numbers. If I put in a really big number, I'm going to get a really tiny number out. This is times 10 to the negative ninth. So like you will move the decimal point 9 places. It's really small. If I put in 0, you may have seen before, I get undefined because 1 divided by 0 doesn't make sense. We can't divide any number by 0. So this graph happens, it really flattens out. It really gets super, super close to the x-axis, but it'll never cross over it. It'll never go negative as long as we put in a positive number. A similar thing happens when we put in a negative number for x. It gets really, really close. It'll never quite hit it. On the other hand, something weird's happening over here too. If I put in a small number, like let's say I put in 1 over 10, the way math works, 1 over 10 is 10. So 1/10 over, a little bit over, is up 10. If I go 1 over 100, I get 100 high. If I want to do 1 over 1,000, it's going to be 1,000 high. So just a little bit over, and it's way up there. It's screaming up there, that big graph. Yet it'll never hit the x-axis either. Again, when I put in 0, I got undefined. It wasn't able to graph it out. So both in this direction and going up, in this direction and going down, all those ways, it's getting really close to the axis but never hitting that. That's something important. It's something called an asymptote. Now an asymptote, oh, it's small. I thought it would be big. It's pronounced asymptote. Ooh, I typed ass. Oh, and now I said ass. Sorry about that. But it's pronounced asymptote. Some people say I'm an asymptote, but that's not exactly what we mean. One student described it this way when we did our exploration last week. He said when he was investigating the graph of y equals b to the power x, he said if b is positive, it will go slightly down but never touch the x-axis. I zoomed in a lot. The more positive, the straighter it gets, but it never goes straight. Great description for what's happening. So an asymptote is a line that the graph is approaching, but it's never going to hit. It gets really, really close. It never hits it. If I look at another example, if we take 1 over x, our function, and we look for graphing form, we know how we normally do that. We take the x value, replace it with x minus h, so the h will move us left or right, and then at the end we add the k. We multiply by a to stretch it up or down, or flip it over. Another way you can write this, because a is the same as a over 1, and you can multiply fractions straight across, sometimes you'll see it written this way, where the a value is divided by x minus h, and then adding k at the end. Either way is fine. They're both acceptable, whichever way you feel more comfortable with. So if we look at this graph, this equation, our h value would be positive 4. Remember, x minus 4 will give you an h value of 4, and the k value would be 2. So what would that do to our asymptotes? Well, I'm glad you asked it. What would happen, in this problem, we say the locator point is 4, 2. So if I graph that locator point, 4, 2 is your locator point. And actually, x equals h, So x equals 4 in this case. Whenever you have x equals a number, it's a vertical line. Y equals number will be a horizontal line. So y equals 2, y equals the k is this line. And so when your h and k are 4 and 2, you get this locator point here, and you get those asymptotes. Those asymptotes will guide you how to graph the function. Excuse me about that. I didn't mean to zoom in. Well, I guess it's okay that I did. So if I see to graph this function here, there you go. The asymptotes are guiding how I graph it. If I had a negative one there instead of a positive one, it would flip it over, of course, and so it would be down in these parts. But when you have a positive a value, it's upper right, lower left. So that's what there is to know about asymptotes. Asymptotes are pretty incredible. Um, we oftentimes show them on the graph with these dotted lines. Notice here also, unlike a parabola and many other shapes, the locator point is not on the graph. The locator point is where the two asymptotes meet. The horizontal asymptote across, the vertical asymptote up and down.